So what I want to look at today is the question of antiderivatives or integrals. So some of you might have heard about this before. Basically, what we want to do is, as this part of the name suggests, right, we want to figure out how to go backwards from a derivative to the original equation. Okay. Now there's a couple of questions that we're trying to answer here. One of them is, if the velocity of a car is represented by the equation v of t is equal to 3t cubed minus 2, what does the position equation look like? So remember, before we would have the position and we'd have to figure out the velocity. Now we have the velocity and we want to know the position. Okay. There's another really important question that comes out of this, and how exactly it's tied we'll show later on. But remember how we could relate the derivative to its original function by saying the derivative is the slope of the original function? Well, basically the same way, the antiderivative is related to the area under a curve. Okay, so if you look at this thing right here, okay, so I've got a parabola here, just like in the question, from negative 10 to 10. Okay, so the equation is y x squared, negative 10 to 10. And what I have is an estimation of the area. Now this is a really bad estimation, right? It uses these 6 rectangles. Okay, so 1, 2, 3, 4, 5, 6. And what you see is a whole bunch of space that is missing the mark, right? And you also see space out here that's overestimating. Okay, so that's using the midpoints of the rectangle. What I want to show you is that if I change this, so I'm going to change the number of intervals, which means that I'm going to change the number of rectangles. Now if I change it to 10, that gets a little bit better, right? If I change it to 20, that gets a lot better. If I change it to 30, better still. So just like our 2 points were getting closer and closer so we could calculate the tangent when we found the derivative, what's happening here is right now this width of the rectangle is pretty big, but as that width gets smaller and smaller, right, so there's 50, 100, as that width gets smaller and smaller, our estimation is going to get better and better until eventually it's perfect. Okay, so that's what the integral is going to help us do. Okay, now we'll answer this question later. We'll answer this question at the end of today. But the basic question that we want to know is, what do we need to take the derivative of to get the answer f prime x is equal to x squared? Okay, so that's the simple case. Okay, so what is f of x? Okay, so think to yourself, I need to have something here, so when I take the derivative, I get that as the answer. Okay, now that exponent there, remember when we take the derivative, the exponent decreases by 1. So that means that my original function had to have the exponent 3 up there, right? Now let's check our f prime, right? So we're going to check our progress, and we'll see that the derivative is 3x squared. Now how do I turn this into that? Well, I divide by 3. Right? So I'm going to divide by 3, which means that I need to divide this by 3. Okay? Now let's check. So now let's get rid of this old guess over here. Okay? And now let's try taking the derivative. Okay? So f prime x is equal to, so that 1/3 can come out, right? And then the derivative of x cubed is 3x squared. Well, the 1/3 and the 3 cancel out, and what we have is x squared. Okay, so what that means is that we had to increase that by 1, but we also had to divide by something. Okay, so let's answer a few more questions now. So what if f prime x is x to the 3rd? what was f of x? Okay, so we know first of all that the original had to be to the power 4, right? Because the exponent's going to decrease by 1 to get to that. And we also know that to get from here to here, I'm going to have to take this and multiply it by 4, right? So to undo that, I'm going to divide by 4, right? And what you should see that is that if the derivative is some x to the n, then the original function is x to the, remember we've always had to increase that by 1, so m plus 1, and we've had to divide by that. Okay? So you can see that if you try to take the derivative of this, you have to multiply by n plus 1, cancels out, and you get n up here, x to the n. Okay? Now, so that's kind of our basic rule, just like we had our power rule. That's our basic rule for integrals. Okay? Now, the way that we write this, so here's some interesting notation. The way that we write this is we say that the integral, so that's the sign for integral. It's a long letter S of x to the n is equal to x to the n plus 1 over n plus 1. And actually, this isn't the only thing, but there's a dx that we always write at the end of that. Okay? Now, I want to have you guys remember where all this comes from. So remember that in the past, we had that d by dx of x to the n was n x to the n minus 1. So remember, the derivative of this was that, and now the integral, instead of doing a divided by dx type thing, we're multiplying by dx. Okay, so it's still the same type of notation, right? The same notation still there. Okay, it's just instead of dividing, we're multiplying because everything is backwards. Okay, so I'll get to a little bit more of a concise explanation why that is in class, but for now, that's the notation that we use. Okay, so let's do an example together where I ask you, what is the integral of 2x to the 4th dx? Okay, so what do you think happens to that 2? Now remember, we're going to have very similar rules for integration and derivatives because they're very similar functions. Okay, so that 2 is going to be able to come out and nothing's going to happen to it. Okay, so just like with derivatives, the 2 is just going to stay there. Now what happens to x to the 4th? Well, instead of x to the 4th, it becomes x to the 5th over 5. Okay, so simplified, that becomes 2x to the 5th over 5. Okay, now that's not it. So that's pretty much the gist of it, but I want to get you guys thinking about one more thing before you go, and it is the question, what is the integral of 0? So what can we take the derivative of to get the answer 0? What do you guys think? 1? The derivative of 1 is 0. Yeah, that works. Is there any other answers? What about 2? Works. 3? Works. Right? So actually any number here, negative 48.5. Derivative of that, 0. Works. So this is not unique. Okay? So this is the last part that we have to put in, and that's the last part that we'll talk about in class. Alright? Thank you very much for listening, and I'll see you guys in class.